and welcome to this Automation Academy Mastering the Machine webinar for the 28th of January 2023. The topic today was system integration, and in particular the Mastering the Machine course that I'm creating for the Automation Academy. Hope you enjoy it. Good morning and welcome to this Mastering the Machine Automation Academy webinar for the 28th of January 2023. And the topic today is a general topic on systems integration, and more specifically on a course that I've been developing actually for a couple of years. I started it 2 years ago and really didn't make much headway on it. And then somebody called it to my attention that is a member of the Academy, and it kind of motivated me to start working on it again. So I'm going to be talking about systems integration and also showing what the course is about. I'm about 5 modules deep on it. Before that, I've kind of condensed this down to one screen. What is the Automation Academy? It is a membership site where I keep training videos on a lot of different topics. Allen Bradley, Siemens, training, little bit of back off. I plan on working on more of that. I think there's a short Omron course in there. I haven't done much work on that either. There's some job and aptitude assistance, figuring out what you want to be when you grow up and that kind of thing. Topics on systems integration, specifically this course, the Mastering the Machine course, which I'm working on. There is a library of lots and lots of documents and software, some free programming software, things like that. Things that are free on the internet in a lot of cases, but hard to find, like Allen Bradley's RS Trainer software. Do have places you can download that. There is a community with interest groups. You do not need to be a member of the Automation Academy to join the community. IO Central, if you type in the address down here at the bottom, community.automationllc.com, you will run into IO Central. And the Academy itself, automationllc.com/academy. And of course, this document up in the left corner, which is the basis of the course that I'm creating, can be downloaded from both my website and my blog, and the addresses are up there in the corner. So what else is Mastering the Machine, right? Besides the title of this webinar that I do every few weeks, and a download that I created, 10 years ago, talking about documentation in systems integration. But it's also a course now in the Automation Academy covering topics on industrial automation. And I've got about 5 modules, but it loosely follows the content of the document. What is systems integration itself? I don't actually define it in the document or even in the course, because you get different answers depending on who you're talking to. If you talk to computer guys, they consider systems integration as all software, right? Just making one application talk to another application, writing software to do that for commercial purposes in a lot of cases, nothing to do necessarily with industrial automation. But, computer guys know how to do that, and they get paid to do it. Creating applications or making different products, even bringing data into Microsoft Excel or Access databases, things like that. If you talk to an industrial controls person, they're probably mostly going to talk in terms of controls and, control panels and writing software to tie different things together, maybe bringing cameras and robots into a PLC program. Maybe that's what they mean for systems integration. Machine building. Sometimes people build a specific kind of a machine and then they have to systems integrate it together with, say, packaging machinery or gauging machinery. And so tying those mechanical systems together, a machine builder may define systems integration as that. In the process industry, completely different thing. You talk to guys that are in oil and gas, and they may be tying pump systems together with piping systems, together with SCADA systems and things like that. So you get different definitions depending on who you're talking to. I'm mostly in the machine building industry. I deal some with process control. Of course, I started in industrial controls, so I really take all those definitions pretty seriously. I'm not really a computer software IT guy, but I have to dabble in it. It really is part of industrial controls, especially when you get into SCADA. So sometimes I have to deal with that, but I don't develop apps for people and things like that. So I don't really consider that part of my definition of systems integration. But basically, the idea is making systems and subsystems work together, whether they're mechanical or controls or whatever. So that's kind of how I would define what systems integration is. So far, I mentioned I've got 5 different sections of the course. The introduction part is really just going over the document itself, which is a document about documentation. I cover some different topics in there, and people can read that document. It's about 26 pages long, and a lot of it wouldn't necessarily apply to everybody's life. So you can read the document itself and probably get most of the information you would want out of the documentation part of it. The next courses I've got evaluation, and I'll be showing a little bit about this. This was an application that I went out and looked at a couple years ago, and I wrote up an evaluation document for this company, and then never ended up continuing that particular project. I gave them a bunch of recommendations, introduced them to some other machine builders, but I did not continue on that job. So I don't know what it turned into, but I wrote up a pretty good document, and it's part of the course. People can download it. Then I get into specifications themselves, and I kind of made up a couple of companies, and I'll show that, just for writing plant specifications and machine specs and things like that, kind of invented something. Applications itself, still working on that somewhat. Quoting, still working on that. How do people quote large machine systems? I've worked for some big companies, so I kind of know how they do that, even though I've never been an apps guy as such, and I've never been a sales guy for large machines. And then the reason I have this question mark is I don't really know how I want to continue this course. Of course, I'm going to put all the kinds of things that I have on my website, like PLC programming, SCADA programming, different platforms. I do a lot of Allen Bradley, Siemens, Beckhoff, that kind of thing. But I don't really know where the course is going to go after that, right? May talk some about, how machines are built. Most of my experience, I don't, personally weld up large welded frames. I did a little bit of that when I owned my machine building company, but built a lot of stuff out of extrusion back in the day. So I may talk some about that. From the document itself, this is part of the introduction. I just say planning and building a system or line can take months or years. Whether it's big or small, it's critical that it meets the budgetary requirements, the schedule requirements, and the performance requirements. So that brings up a topic I might get into project management, which is kind of an important part of systems integration and machine building also. In the introduction, I reference a couple of machines I built. There's one of the ones out of extrusion, right? I built 12 of these for a company called Howmet in East Tennessee. Built a lot of systems for them. And this is a picture of one of these small, it's like a ceramic press. It heats little blocks of ceramics and presses these turbine blade castings inside of them. And the little orange machine in the back is something that they had. And then I built these little roll around carts, and you could jack them up. You can see these. Built 12 of those. Otherwise, it wouldn't have been economical to build just one, right? And then I worked for Wright Industries, and a couple of years later, I did this system. And you see a lot of extrusion here, but this was not an extrusion machine. You can see there's a lot of metal on it. It had winders, unwinders, things like that. Ended up going to South Korea, so I got to go there and start that machine up. But that's an example of a much larger machine. So quoting and designing a machine like that is a whole different animal than quoting and designing a little cart like this, right? This didn't take very long, and it didn't take very long to price up. But a system like this involved a lot of things, and it was truly integration because, for instance, I was the project lead on it, and I had to go, on several runoffs for this machine and some other ones. To Telsonic, for instance, they make ultrasonic welders, had to go to the packaging machine people and run their machines off. And then, of course, design a lot of the stuff into that. Part of this introduction also, it's part of the document. I talk about different ways that you can do systems integration. You can do things in-house, right? Some companies have the capability to do this. They have a big machine shop. Sometimes companies like Denso out in East Tennessee, they have their own machine building company right inside of their company. It's called the M&T department. And I actually go through that in the introduction, talk about them a little bit. I would have killed to work for the M&T department back when I got out of college, because they built pretty cool machines for the automotive industry. Denso makes alternators and various other automotive parts, and they build their own machines to do that. So that was kind of cool. You know, if you do that in-house and you have your own machine builder, you're buying the parts directly. There's no markup, but it takes a lot of resources, right? They have a lot of employees. They have their own machine shop, things like that. Then you can kind of go in between. You can say, I'll bring in a bunch of different vendors for the machinery, but I'm going to integrate it myself or hire a systems integrator to help me put things together, connect things up, maybe wire some things together. Or you can go to somebody like I used to work for, Wright Industries, and get a turnkey solution, right? They'll provide everything. They'll mark everything up, but you'll go do runoffs for the machines if you work for a company like that. You know, take responsibility if the different, you know, ultrasonic welders and things don't work. It's the highest cost, but somebody else is taking care of everything for you. So some of the bigger companies like Ford, GM, 3M, Procter & Gamble, they mostly go out to get all those systems built, and they'll pay that extra markup for turnkey solutions. So that's in the introduction document. That's for free download. People can just go get the Mastering the Machine document. This is the plant evaluation I talked about, and I actually had a webinar on this. So it's on YouTube. You can find it here. It was the 22nd of January, 2021. So it was, I guess, 2 years ago that I did this. And this was the solution that I proposed, which was basically unloading. They made bags of soup, and you unload the bags of soup into this system, and it was going to be maybe robotic unload to replace the people. And then you would put them in boxes, and the boxes would automatically be loaded onto carts. And either the cart would be brought over to here and then automatically unloaded into these freezers, or you could do it with an overhead conveyor. And like I said, I did some of the preliminary specifications, but I don't know whatever turned out from this job. I introduced them to some other machine builders, pointed them in a few directions, and then, you know, moved on my way. And this was in the middle of COVID. So I'm not sure what they did. You know, they make this soup, and you don't charge a lot for bags of soup, but they had a whole lot of people pushing these carts around that you see here. And this is in a freezer, and they'd go from the hot soup making area into the cold freezer area. And it was quite an application. It probably would have been a several $1 million job, I'm sure, plus really taken a lot of infrastructure work hanging all these conveyors up. And I went and found a lot of resources, but I wasn't involved in quoting it or anything else. So that was an analysis that you might do and then build the machines. Specifications themselves. What I did here, and this is kind of interesting in the course, I'll show a little bit about this. I invented a company, right? And I did a plant specification. Looks kind of like this. And this is in general what you might get from a plant, right? They'd give you a map of the layout like I showed you here. And then they'll give you their electrical specs. They'll say, well, we got 480 3-phase coming in, you know, with a 2000 amp service. This is a pretty small company. But the main breaker panel, here's where it is. You got a bunch of 100 amp breakers. So I kind of invented all this stuff. I didn't use a real company as the basis of it. I just said, this is an imaginary company in my own hometown. And I called it Alco, just make up a thing here. Said they got, you know, a couple compressors, alternate duty, gave the specifications for the compressors and how much CFM they produce, and then they run all the piped air to the different manufacturing areas, gave them a map, right? So this is stuff that a machine builder would receive, and they would then quote based on all this information they received about the plant, right? So that's all this stuff. Here's our control specs. And I used Allen Bradley Preferred because in the US, that seems to be 70% or so of the PLCs. And then I use Siemens and Beckhoff Automation Direct. Maybe they have a few other machines and they say those are allowable also, so that you don't end up with 27 brands of PLC that no one knows how to work on. And I mentioned here like PNP sourcing. That's what most people in the US use for sensors. Takes a positive signal, puts it into the IO cards. Sometimes plants are going to specify things like that, and often they won't. They won't even have any information on what they require. And then people put all kinds of things in the plants, right? You could have quite a mishmash of equipment if you're not careful. Pneumatics, SMC Preferred. I work a lot with SMC and Festo. There's a lot of other brands, pneumatics, things like that. Standard or metric fittings. And this is very purposely generic. And then I mentioned safety. If people want to know more about this, there's of course downloads in my Automation Academy for safety. There's a whole lot of write-ups on that. If you don't understand safety systems and what Cat 3 and Performance Level D SIL requirements are, you can go find that out. Next thing I did was I specified the machine itself. I said, Alco Manufacturing is looking for a machine for filling and inspecting boxes of beads. And like I said, I invented this just because I have actually built this machine. That's one of the reasons that I use this as an example. This is a machine that was in my old training facility. And so I'm able to point to areas of the machine, and I have video of it running and that sort of thing. So I give all the specifications of what is required. How fast do we need to produce all these beads and things? And this is what you would get, again, from a company requesting a quote from you. We need to produce this product and we need to make this many parts over this much time. By the way, we run 2 shifts, six days a week, something like that. They'll describe the product itself. And often they will give you product, right? They'll give you some samples of it and they'll say, this is really what we want. Sometimes if you're doing automotive, that product will not actually be the final product. It's a prototype, and that can cause a lot of problems. I've had to work with a lot of product that was not really ready yet. Like, okay, we think it's going to be this alternator that's our new model, but it's subject to change. The tooling may change and things like that, which involves engineering change orders later. So a lot of this was on, like I said, on documentation and things. There's the rate for their requirement, and the parts have to be inspected. So what this is based on, like I said, I used to have this machine in my facility, and I used to put people through this course. And it took these little beads and it filled the boxes. And I kind of invented some, hoppers and things that are not part of this actual machine. I didn't have vibratory bowls. I just stacked the beads in the tracks and then escaped them into the boxes. Used a pick and place to set them on a dial. Used a camera to inspect the parts. And of course, all these numberings and things would not be on the probably the machine spec or on the final description. This is really for more people who have to track product through the machine. I would give them this document. I don't know if there's a picture of it in here. I did give them an IO list. So one of the reasons I use this as an example is because that way I didn't have to use an imaginary machine. It was a real thing that I have lots of documentation for. There's some of the touchscreens from that old project, right? And so I would give these to students and then say, go ahead and use these touchscreens and write your program. And I would give them the system. And so this is just an example of, a plant spec for this product. And then the goal is to describe how that machine was built, right? And probably bring some things like, we're going to use a metal base instead of extrusion type framing for it. This thing sat on a counter in my shop. But if this was a real machine, there would be a lot of detail going into designing it and pricing it and things like that. Applications. So the fourth course in the fourth module in this course, I go through applications, and this is a timing chart that I've used in the past. And I spent probably day before yesterday a little bit of time filling this out. And what it shows is justification for the speed of the machine. So it's going to fill beads, and it takes 0.8 seconds per bead to put them in the box, and you can do up to 15 of them. So they need, 15-second cycle time to fill one of these boxes, and then it indexes. And so I've got the pick and places, I've got the bead escapements, and I had to fudge this a little bit and then, justify the timing of the machine, because you haven't built it yet. You don't know how fast it's going to really operate. So timing chart, stations, description of the stations. To price this up, the applications guy first has to prove that this system's going to work without actually building it. Sometimes people will build a proof of principle machine. It's called a POP, and the customer usually will pay for something like that. Sometimes the integrator will even pay for it. In the case of Automation NTH, I think they've built some POPs that they paid for to prove to their customer that that this machine will work at the speed that it's designed to work, right? Or sometimes the customer will pay for it and then keep it later. Again, just proof of principle. Mechanisms themselves, all these will be laid out. How are we going to build this machine? Sometimes people draw this by hand. I used to do that for a lot of my systems. I would get graph paper, and this is a general layout of the machine, and I had experience with the different mechanisms and things that were in there. So I would hand draw it and use that to count IO. And that way I could price the control system. Now, most applications department have a tool that looks like this. And I've actually got, let me see here. I've got that tool. I've got a couple things here. One, here is a parts list that I use internally, master parts list for a lot of different things. Let me see if I can scrunch it down. So I have tabs, and these are, I don't do a lot of machine building anymore, but this is what the price list might look like, right? For mechanical parts, where do I get it from? What was the date that I actually got this quote? Is my pricing still accurate, or has it expired, right? If it came, like I got PLC parts in here and a lot of my dates were 2013, I would guarantee you that most of these parts are more expensive now. So this is an example of something that I use internally. And then what I do is I take these parts and I put them into another spreadsheet that looks like this. Okay, and this is an actual tool. It'll save you a lot of time if you were quoting a large machine. And again, I'm going to make this available for download in the course itself. I don't think I've put it into the quoting module yet, but this is a kind of a cool tool. So for each station, right, it has a actuator 1, 2, 3, 4, 5, whatever. You can go back here and there's a list of all of the actuators, which effectively are stations, and then the pricing for them. So the actuator pricing them itself, and then there's miscellaneous added to it. And then all that is summarized on this sheet. And so if you take all this, you can see here, I've got total cost, and this includes hours and it includes parts. And right now it's at about $35,000. I want to say, I think I built the top part of that system that sat on my counters for about 30,000. I machined some of the parts myself. I got things like the conveyors at like 50% off, went to QC conveyors and they sold them to me pretty cheap. Then there's a margin 44,000, but you can see here, I don't have my controls parts in here yet. So I'm still working on that. You can see some of the pricing in here. Just the PLC alone, I inserted this morning. It's a $4,000 PLC, and that's not even included yet. So this is a pretty elaborate spreadsheet, and I'm going to make this available for download in the Academy for people that want it. It's not there yet, but it'll be part of this module. And so when I finish the quoting module, I need to make sure it's done, right? And actually, this is taking me quite a while to get done here. In-house fab, QC conveyor. A lot of these tell where the parts are from. Rates for project management, electrical assembly. That's how, right? You put the number of hours that it takes for electrical assembly of different things. Like this is a feeder bowl. Feeder bowls come in already made, right? But there's, say, an hour of electrical assembly involved with it. And then the electrical design would be the CAD guy has to show how all this stuff was wired. So he's gonna put that in his schematic drawings, and you have to accommodate for all that. And then here is the rate that the electrical design guy you would be paid, $60 an hour internal cost. And a lot of this comes from my experience at Wright Industries. So the software guy internal cost was, what does it say there? $65 an hour. It's higher than that now. I'm sure Wright, which is now owned by JR Automation, probably charges more like $80 an hour internally, even though they don't necessarily pay their controls guys that. That's including overhead and everything else. They put all these rates in here. So project manager cost, electrical assembly cost, electrical design, which is CAD, mechanical assembly cost, the assembly guys in the back, mechanical design, which is again CAD, usually a mechanical engineer is doing all that. So you add up the hours for each one of these stations, right? Some of them are duplicates. So this even says here, duplicate design hours removed, right? This station is just like station 2, and station 4 is the same. Station 5 is a pick and place. How many hours go into that? It's an XZ with a gripper. So all this is in here. All the hourly costs are added up here, so you can tell how much am I paying in labor for each one of these stations, and all kinds of stuff in here. So for every station, and again, a map of this system is this. So the ultimate machine that's going to be built in this fake company with this fake machine will look like that, right? So that's the general layout of the course itself. So number 5 there. And I'm getting a little pop-up message saying something about me scrolling and that the quality of the video may not be great there. But anyway, that's an overlook at the course itself. As I mentioned, I don't know what I'm going to do next. I don't know what the module after the quoting would be, but after a quote is received by a company, they award a purchase order. Probably what I'll do at that point is I'll talk a little bit about the terms that people get. And I had to experience this a lot. I owned a machine building company back in 96 to 2006. And our terms, a lot of times we would offer 40-40-20, which was a 40% money down, 40% upon completion of the machine in our shop, and then 20% after the machine had been run off at the customer shop. Not every customer would accept those terms, and so we had to work with those companies. The ones that I showed here, I did a lot of, I did a lot of machines for this company, which was Howmet, and they were owned by Alcoa. And when I started doing work for them, I think 96, I did some small machines for them, small stations, and they were net 30 days, net 45 days. And by the time I built these machines, they were up to net 90 days. So what I had to do, in the machine building industry is work very closely with the mechanical engineer, and he would give me inside information. He would say, here's a way I can work with the folks to make sure you get paid. By the way, you can ask for more money down, for instance, maybe 50% down, and I can probably shepherd that through so that you're not sitting on so many parts. That's the expensive part of building this stuff. I want to say this line, including delivery to South Korea, was probably $3 million. And we had another machine that went out at the same time. I also programmed that, and that was a filter tester. So this made respirator filters for 3M. So 3M has these masks, and they made the respirator filters for them. And it was all kind of coming out of the 9/11 experience, when all the first responders had to go into with all the dust and all that kind of stuff. So they made these respirator filters to go inside their respirators. And I think you could just buy them at Home Depot. They were pink and had the part number of the filter written on them. But, big system like this, obviously that spreadsheet that I showed you, that would probably take, at least 2 weeks to quote it. And you have to kind of design the machine before you quote it, at least conceptually, right? You have to say, this is what we're going to build, get all the pricing for everything, lay out all the mechanisms and say, this is how it's going to work. So it can get pretty complicated. But that's a general overlook at what the systems integration, industry is like. And then, like I said, how am I going to continue this? Talk about getting the job, then talk about building it. Probably talk a lot about mechanisms and different things that you would need to know to quote the machine. So pick and places and escapements and packaging equipment, and maybe like in that machine I was showing, ultrasonic welding. I knew something about that. I had done, jobs with small ultrasonic welders, but I went up to Telsonic, which was a Michigan company, and learned more than I ever needed to know about exactly how those little heads vibrate, and how they put kind of RF frequencies into them to vibrate on the material, and it would weld the material together for the filters. So I learn a lot when I go up and do those kind of things. So a quick note about that, applications. Applications guys are usually experienced engineers that have done design work. They've done mechanical design, they've done electrical design, they've built machines for a long time, because they have to know about all those different mechanisms and things like that, what solutions are out there. So a good applications guy is usually a very experienced engineer that has actually worked in building things and programming things and whatever. They at least know something about it, about how many hours things would take, et cetera. And then at Wright, of course, they would draw on the mechanical department or the electrical, controls department. They could ask some of the guys in assembly. They would, get the resource information on quoting these jobs and things, and get expertise from them. Also, there were several applications guys. So if they didn't know about something in systems integration, they could go ask somebody else and say, how would you do this? So there's a lot to it. And bigger companies have those kind of resources. They can all talk to each other or draw on the controls department. My small company, I started in my garage and, migrated into a little thing, became kind of a panel shop, and then started building machines. And I got my experience from working closely with a guy who owned a machine building company. And then after a few years, he started building standard machines instead of custom machines. And I kind of took over his custom machine building business. And I learned the hard way about the expense of the capital equipment, and how hard it is to run a bigger company like that. We only got up to about 15 people, but it was very capital intensive. And I don't necessarily recommend anybody starting a custom machine building company. I really winged it. My wife picks on me some for that, just for, the way I, went into a garage and decided I could start doing this. And, company got to a decent size after 10 years, but it was like herding cats. And there was a lot of things that I had to do that I didn't have other people to do. So it was a really not something, I enjoyed a lot of parts of it, but it was very time intensive, and I was working 7 days a week. So I don't recommend that you necessarily get into that unless you're willing to give up your life for it. You can do okay, we could make a couple $1,000,000 a year, and we could lose, maybe over, $1 million. So it really depended. You could make money on 9 jobs and lose it all on the 10th. That was kind of the way I looked at it back in the day. And then I went to work, like I said, for JR, Wright Industries, big JR Automation, and then left there in 2012, started contracting and teaching, and that's how I ended up where I'm at now. But I'm able to share some of that information. And like I said, I had to invent this little company to kind of wing it along the way. And that's pretty much the end of the presentation of the course itself. And I can open it up here for any questions anybody would have about systems integration in general, machine building, or the course, or anything else. Anybody have any questions? I think we had a couple people, and some of them have disappeared. James, I guess, is still here. Any questions, comments? No questions in the chat yet either. So anyway, this is a pretty good representation of what it would take to quote a machine and all the documentation that goes into it. Building the machine, since I built it, this little machine, I actually built myself 100%. So when it comes time to talk about exactly how it was built, I'll be able to go into great detail about, at least the top part of it. And like I said, I have video of this thing running. So it's going to look like, somebody ordered the machine and here it is running in the plant. And I'll try to crop up the video and everything to make it look like a little more industrial system rather than a training system. But this was a pretty cool little machine. It was in my training facility until the tornado hit the facility in March of 2020 and took it out. And, I got to rescue some of the little components and things, but the main frame of it and the conveyors and everything got smashed up. And Automation NTH sent a truck out to pick some of it up. And then somehow the conveyors and the extrusion, at least most of it, evaporated somewhere over, a few months of sitting in warehouses there. And they moved into a bigger facility. So during that time, I think the system got cannibalized. I really would have appreciated getting parts of it back, but anyway, it did disappear. The next webinar will be February 18th, as far as I know. Topic unknown. There's a few, I used to have guests on this webinar pretty often, and I do have Scott Weeks from Automation NTH who said he is willing to sit down with me and talk about NTHU, right? NTH University. And so we may do that, talk about what NTH is up to now. They are a systems integrator, they're a machine builder, and they have a really good apprenticeship program. And I kind of, let's see here, there's their logo. I do 2 weeks a month with this company, and help Scott is in charge of NTH University, and I help him with that. I teach the in-person classes and design some of their curriculum. So that's kind of how I got involved with Automation NTH. So we may do that, next webinar, or it could be on something else. I always like to have guests, people that, either own companies or are involved in a really cool project. Would love to get somebody like Jacob Sagatowski. He's a Beckhoff guy. I'd love to interview him, or Dustin Hullett on Beckhoff. I'm working a lot on Beckhoff now, so would love to get some of those guys as guests, or maybe an Industry 4.0 person, or maybe even I have an intern now, right? I have a guy who comes in just in the afternoons. He's a high school senior, and he's working on some Arduino and Raspberry Pi and microprocessor stuff. So maybe I'll talk to him about the projects he's doing now, right? He's playing with a Arduino equivalent, and by that time, maybe he'll have some things moving around that I can show. So I'm not sure what the topic will be, but in any case, the next one should be February 18th, which is 3 weeks from today. I can do Fridays if anybody sees this on YouTube or something. and wants to volunteer to be a guinea pig and let me talk to him, I could do either Friday or Saturday on most weeks. But the topic is unknown, and that should do it for me. If there's no questions or comments or anything, this was Automation Academy Mastering the Machine webinar, and I went to a little more depth on what Mastering the Machine actually is and the course in the Automation Academy. Would encourage anybody to join IO Central. It's free. Or join the Automation Academy. It is not free, but I would promise you it's worth something, right? $9.99 a month for the just being able to download documents and some of the videos, $29.99 a month for taking all the courses and things, including this course, the Mastering the Machine Systems Integration course, which has a bunch of downloads associated with it. So that's it for me. Thanks for attending. And thanks to those of you on YouTube who watch this later.